Okay, this video is still practicing with Unit 1, talking about functions and independent relationships. First off, we're trying to figure out if this is a function, okay? But when it's a function, basically what you need to remember is that no x numbers can repeat. Now we also talked about, so basically, let me give you an example here. So if I have some ordered pairs, in this example, when I go and I underline the x's, remember, because it goes x, then y, all these x's are different. So that means that this is a function. The y's don't matter at all. We don't do anything with them. Now, if we had this, and I go and I underline all these x's, if you notice right here, I have -6 and I have -6. Since they are the same, this is not a function. Okay? Now, another way of being able to tell if it's a function or not, I have a graph. So say I have some sort of line. And it's something called the vertical line test. If I draw a vertical line, nice vertical line, huh? And it only touches in one spot, then it is a function. Because there's only one of the same x number. There's no other x. So it'd be x, maybe be 5, 1. There's no other like 5, 2, 5, 3, anywhere on this blue line. Now, if I have this right here, here's my graph. Say I have, I don't know, let's make a straight line here. Let's make it look like this. And I drop a vertical line and it crosses. It touches in two spots. So really, when you look at it, this would 1, 2, 3. Say this is over 3 and up 1, 2, and down 1. So like say that this is 3, 2. This one would be like 3, -1. Well, see, they have the same x's. And we already said if they have the same x's, they are not a function. Okay? So now if I go back, take a minute, pause the video, and try and answer the first 4. Well, on number 1, I'll underline all my x's. Do any of those numbers repeat? No, they are not. So yes, this is a function. Okay? Next on number 2. Number 2 is a vertical line. That means it goes up and down. Well, I just said if we draw the vertical line and it touches in more than spot, then it's not a function. Well, if it is a vertical line, it's going to touch in every spot. So it is not a function. Now this one, what I would do is I would go into y equals in my calculator and put 3x plus 4. Whoop, get the 4 there. And when you go to graph it, you're going to see that the line, let's see, it'll start at 4 and it'll go up kind of like this. It'll be a straight line. This is a function. Now on number 4, when you go to graph it, and you go to y equals and put in there -5x squared. As you go in there, you're going to see the graph, and it's going to open downward like this. If I draw a vertical line, it only touches in one spot. So yes, it is a function. That is okay. All right, there's the next 3. Go ahead and pause the video and see if these are functions. Number 5, if I draw a vertical line, it touches here, touches here. Well, this is not a function. Look, 1, 2, 3, 4. This is 4 and 4, 2. And then you've got 4, -2, it looks like. Well, both of these x's are the same. So this is not a function. Number 6, Right here, this is called mapping. And remember I've said to make it and go -3, 1, -3, 3, and 5, 2. Okay, because look, -3, these are the x numbers, these are the y. And then you can write them out as an ordered pair. That's the easiest way for me. And I underline all my x's. Sure enough, my x's repeat, so this is not a function. Number 7, if I draw a vertical line, it touches in one spot. So this is a function. There's my notes. All right, next one. True or false? It says all graphs are functional relationships. And no, it's not. I guess I shouldn't have told you that already, huh? Because this is a graph if I go like this. But if I draw a vertical line, it touches in more than one spot. So it is not a function, so this is false. Pause the video, see if you can see about these three right here. Okay, on number 9 it says, there's a functional relationship between a person's age and height. Well, do they go together? Like as you get older, do you get taller? Yes, there is. This is true. Number 10, the age of a tree and its height. Well, yeah, the older the tree gets, the taller it gets. So this is true. The next one, is there a functional relationship between a person's hair color and their IQ? Okay, I know there's a stereotypical thing saying that blondes are dumb, okay, but I'm blonde, I'm not dumb. So no, there is no correlation. So this is false. Next, right here, pause the video and see if you can come back and figure it out. This says Haley's grandmother Gertrude wants to plant a rectangular garden in her backyard. In order for the garden to fit in Gertrude's backyard, the length of the garden needs to be 3 times the width. Okay, so this is the graph for 3 times the width. Does this graph represent a function? Well, do the vertical line test. If I draw a vertical line, does it only touch it once? Yes, it does. So yes, it is a function. What is the independent quantity? Independent is the x. Guys, the x on here is always down here. Y is up here, and the dependent is the y. So the independent quantity is the width. Because in a graph, independent will always go down here. Dependent will always go on the side, which is the area. Now, right here, the blank of the garden is a function of its, okay, so y, remember we talked about y is a function of x. So what we have here is the area is a function of the width. Next, pause the video, see if you can answer 13 and 14. I'll even try and move up 15 here, and then you can do that too. There we go. Okay, number 13, the height of the soccer ball depends on how many seconds have gone by when it was kicked. So we've got height and we've got seconds. What is the dependent quantity? Okay, dependent is the end result. As the time goes, what happens? The height of the ball. So this is going to be my dependent quantity. You should have height. You also need to remember that seconds, time is always going to be your independent variable, or more often than not, it is normally always going to be that. Number 14, the volleyball team collected $300 at last Friday's game. The amount of money made at a volleyball game is determined by the number of tickets sold. All right, well, what has to happen first? The first thing that has to happen is you got to sell tickets. So the second thing is you make money. Well, it's asking us for the independent. Remember, the independent is the cause. It's the first thing. So the first thing is the number of tickets sold. Number 15. Same thing we talked about before, and we've got a job at Kroger. But this time it wants to know the independent variable. What's the thing when you have a job that happens first, that you got to do first? Well, first you got to earn money. You got to work. See, remember, look up here. Y equals 7x. I also know that x is my independent. Well, right there it has h, the number of hours. So right here, it's not the wages. It's not the wages. It's not the number of days worked. Now, is it the amount per hour, or is it the number of hours worked? What is it you have to do first? Well, first you have to work. Well, let's see if I can pull this up. Here we go. There we go. So your answer should be A. Next, pause the video. Come back and see if you know what the answer is. This talks about Rachel earns $7.50 per hour working at Dillard's. Her total pay is represented by the equation W equals 750H, where W is the amount of her wages and H is the hours worked. Which of the following statements is true? All of these statements have depends on. Okay? Y depends on X. The dependent depends on the independent. Okay, well, first off, what's the independent variable? You have W and you have H. Time, there it is. There's our independent variable. Wages is my dependent. So let's put that in there. Dependent goes here, so we've got wages. And then you've got depends on. The independent, which is the hours. So which one says that? The number of hours depends on the amount earned? No. Amount earned per hour depends on the number of hours worked? No, it doesn't change. When you start working, you don't earn more or less. The amount of your wages depends on the number of hours worked. Sure enough, your wages will increase the more you work. Okay, here's the next one. It says using number 12 above. Where's number 12? Oh, that graph right there. Let's see what our question is. Let's see if I can find my pen here. Oh, there we go. Let's go here. Write a function to represent the situation. Okay, so let's see here. This is kind of acting kind of funny here. Let's write the function. It says that the length, the y, equals 3 times the width. So actually I should put L. L equals 3W. There's my equation. So if I go back over here, L equals 3W. So now it's saying what is the area of the garden if the width is 12? So right here my pen is acting kind of weird. L equals 3 times the width. The width is 12. So my length equals 36. I don't know why it's not showing it. What is the width of the garden if the area, oh, it's not area, it's not L, is it? I should have area, sorry. Did I doing that right? Let's see. Sorry, I need to look at this a second. I was doing this too fast. It talks about the width, and it says the length is 3 times the width, and area is length times width. So I did mess that up. Okay, so let's go back and look at this. I'm sorry. Let's go back here. Let me erase all this real quick. Okay, I know that area is length times width. Okay, my length is 3 times the width. So I've got area equals 3 times the width times W. So I've got my function would be the area equals, I don't think it really meant to do this, but I think it really wanted you to do what I was doing where it talks about, oh goodness, looking confused here, aren't I? But that's okay because we're working through this. Let's see, when the width is 1, the area is 3. And the width, yeah, because length times width. So then right here, the length of the garden needs to be 3 times the width. I think it's supposed to be the area of the garden needs to be 3 times the width. That's where I'm getting confused here. The area is 3 times the width. Because right here, 3 times the width, no, maybe not. The length is 3 times, so if the width is 3, the area is 27. So I've got 3 squared, which is 9. 9, sure enough it is. Okay, so when we go to write this, man, kind of crazy on this one. Okay, 3, then I've got w squared. So right here, to find the area, I have 3 times 12 squared. So let's see. If you put that in the calculator, let me move this down. I've got 3 times 12 squared, which gives me 432. Okay, now I totally probably confused some of y'all. Let's see what we got here. Okay, let's try this one. Let's see if we can get this one going. The cost of renting go-karts and Ted's go-karts are represented. There's the equation where C is the total cost and M is the number of minutes the cart is rented. Fill in all the portion here, or all the process here. Okay, first off, 30 minutes. Now what I would do, I wish I could see this here, right? Okay, 1/6 x plus 30. If you go into y equals in your calculator and put in there 1 divided 6 x plus 30, press second graph. You can look and see and go down to where it's 30 and find out. Let's see if I can't seem to see my mouse on here. 35, and then when it's 60, I have 40. And then when I have 90, that is 45. Sure enough, it's 45 and 50. It says if you rode the go-kart, well, and how are you getting this? Okay, let's see here. I've got 1/6 times 30 plus 30. 1/6 times 60 plus 30. 1/6 times 90 plus 30. Now, if you rode the go-karts for 75 minutes, what was your total cost? So what would happen if x was 75? So you go in, I go in my calculator and I'll press second graph. I'll press y equals, put in there 1/6 x plus 30. Do second graph. And then I can look and see where x is. Where x is 75. I get, oh goodness, come on down here, 42.50. Well, you can go 1/6 times 75 plus 30 and get the same answer. What is the independent variable and the dependent? Independent, what's the thing that's happening first? With the beginning result right here, this is my x, here's my independent, the end result is what I've got to pay, that's my dependent. So if I go down here, my independent is going to be my number of minutes. My dependent, my end result, is the total cost. Now it says, what is the constant in the equation and what could it represent? The constant. Okay, I've got 30 right here. And that's my constant. It's the thing you pay one time. And I don't know, maybe on the go-karts, maybe you're renting the go-karts to go on the beach or somewhere down a road on an island. So I would think that it was a deposit. It could be, you could write initial fee or deposit, but it's $30, and I'm going to put down that it's a deposit. As long as you wrote that it was something that was only a one-time fee, you should be okay. The next one, here we go. What is the relationship? Let's see. Let me see if I can move these up a little bit so that we can see it. We're at least going to try and look at the first view here. All right, so let's look at this, pause the video and see if you can answer this question. Now it says, what is the relationship between the figure number and the number of dots? Well, if I went to go make a table, first thing I would have is the figure number and then the number of dots. Whoops, D-O-T-S. There we go. It's because the first figure number has 1 dot. The second has 3. The third has 5. And the fourth has 1, 2, 3, 4, 5, 6, 7. What's the independent quantity? What's the thing that's happening first? Here's my independent. It will be the figure number. The end result, after we go to find the figure number, you're going to find the number of dots. So that's your dependent quantity. Now, it says, what is the 8th figure? If you look, what is it increasing by? It's increasing by 2 each time. So let's see, if I put 5, 6, 7, 8. It's going to increase by 2. So I'm going to have 9, 11, 13, 15. So the way I would do this is that it's 15. It says, write a sentence describing the relationship between the number of dots and the figure number. Well, what's happening? Write a sentence describing the relationship. Okay, when we write a sentence, we're going to use the phrase depends on. Depends on. Now remember, y depends on x. So the number of dots depends on the figure number. The next one down here, it says circle the statement describing the pattern between the dots and the figure number. It says the number of dots is the figure number squared. So let's see, the figure number, 1 squared is 1. Is that the first one up here? Let's see. Oh, it is 1, 1. Let's see about the second one. Set 2 squared. 2 times 2 is 4. Does that say 2, 4 up here? Nope, it says 2, 3, so it's not A. Letter B, so let's see, let me erase this here. Where we go here. Oh, I wanted to erase, not write more on it. The next one says the number of dots is 3 more than the figure number. So 3 plus the first figure number? Nope, the first figure number is 1. That would equal 4. This one says the number of dots is 1 more than, let's see. Let's go down here. 1 more than the figure number squared. 1 squared is 1, plus 1 is 2. So is the first figure number 2? Nope, the first figure number is 1. I'm supposed to have 1, 1. I hope that this next one will work. The next one says it is 1, less than, twice the figure number. 2x minus 1. So let's see, 2 times the first figure number minus 1 is 1. Let's see. 1, 1 sure is. 2 times the figure number minus 1. 2 times 2 is 4, minus 1 is 3. Do I have 2, 3? Yep. 2 times the figure number minus 1. 2 times 3 is 6. 6 minus 1 is 5. 3, 5 sure is. And I bet 2 times 4 is 8. Minus 1, that's 7. Yep, that's what I have, so my answer is D. Next one. Oh, this is the last one. What would the sixth term in the pattern be? Well, for me, the first one is 12. Let's see here. The second one, I lied, it's not the 12. Somebody tell me here. The first one is 5, right? Because here's the first one. Second, third, and fourth. So the second one is 12. Third one is 19. The fourth one is 26. They want us to figure out the sixth one. So I've got 5, then 6. All right, so what's happening? I've got 7 being added, plus 7, plus 7. So let's go right here and take 26 plus 7, which would give me 33. So plus 7. And if I did it again, that's going to equal, Oh, I wrote plus 3. Oh no. Should be plus 7. I have 40. So my sixth term is 40.